thank you for being here. And I just want to share a little bit about Suzanne. You heard a little about her in the awards breakfast, but I first met Suzanne 3 years ago now. She was a panelist at an Economic Development Council Sustainability Conference, where she was one of the featured panelists. And she talked about what she's been doing at Hunt Country Vineyards, which is her family's 7th generation vineyard in the Finger Lakes on Cuba Lake. And she also brought in, obviously, her incredible expertise from her consulting business, HuntGreen. But I was so impressed that there was a winery in the region that had geothermal, had solar, had wind, was really working actively on renewable energy and anything that she could do to help others in the region, not just her family's winery, but the other vineyards and the other farms, to help them switch to cleaner technologies, renewable technologies, as a way, in part, of combating climate change and protecting them from what will come. So when I introduced myself to her afterwards and said, I've been thinking about a private label wine someday when we get a food and wine license, I know her first thought was, why is somebody from a zoo talking to me? And right? She's admitted that. And now she's a trustee. So she's one of the believers who understands that the true role of zoos is about teaching sustainability and inspiring future generations. So she founded HuntGreen LLC in 2007, and her clients include private equity firms, government agencies, UN bodies, clean tech startups, Fortune 500 companies, and nonprofits. She's a passionate advocate for renewable energy and sustainable practices, and has a particular interest in helping to accelerate the clean energy transition underway in New York State. She was a senior advisor to the Carbon War Room and directed the World Watch Institute's bioenergy program. Her work has been featured in Time, Forbes, Scientific American. She herself has been featured on CNN International, Voice of America, National Public Radio, and MTV. She's author of the book Biofuels for Transportation, Global Potential and Implications for Energy and Agriculture. And in her spare time, she harvests grapes, makes wine, and is a singer-songwriter who co-founded the Unity Concert in South Dakota. So that is Suzanne, your moderator. Thank you.
Thank you, Pamela. Well, you all now know how persuasive Pamela is and how successfully she gets folks to do volunteer work for her. Huge thank you, Pamela, for making this happen. Really, she is the force behind this. You've all now discovered a little bit of the brilliance of Bill Browning and the depth and breadth of his work. But I just wanted to, just on a personal note, say that having been friends and collaborator with Bill since 2005, maybe, one of the things that I appreciate most about Bill is actually his giant heart. And I think at this point in our history and the divisiveness of the public square right now, approaching a lot of these challenges with an open heart and empathy and the desire to truly understand on the human level is essential. And so I just want to throw that. We're going to do a lot of techie, we're going to geek out, but I want to just throw that so many of these problems at their core have a human element. So a lot of what we do is really dealing with that so that we can get to the technical solutions. So speaking of technical.
So what we thought we'd do is re-explore the presentation that I did earlier, but do it as a more interactive and break it into more discrete chunks and geek out a little bit more on the science, if you're okay with that. So we'll go back and we'll start with the biomimicry stuff. And the term really comes from the wildlife biologist Janine Benyus. And there are folks at various universities who are interested in this. There are some folks at RIT, some folks at Rensselaer here in New York who've been digging into this. There are a lot of biologists who in New York State who have been making this move into functional biology, which is sort of this beyond just sort of categorizing what's the species and what habitat, it's asking, how does this species do this or that? How does it cool itself? How does it keep itself warm? How does it shed water? All these different really interesting challenges that other critters have used different ways of solving than we have. And so it's not trying to, we're going to grow a rabbit's ear. We're going to understand how that rabbit ear functions. And so I gave some examples on shedding water earlier. Let me give another set of examples. This is efficient fluid movement. And so the first one, owls are pretty amazing, right? Here's this big predator bird that's hunting at night. And so the mice and the things that it's hunting are paying attention more to sound than sight. And so if the owl's really noisy, it's not going to catch that mouse. So the owl had to develop a mechanism by which it could fly really, really quietly, which also means that it makes for a very efficient flight, looking at drag, and particularly reducing drag. And so the owl does that by these little feathery edges, little light, fluffy edges on the owl feathers. If you ever found an owl feather, you notice it's so much softer than a normal feather and has those sort of trailing edges on it. So this is a company that said, okay, could we make fans more efficient and a lot quieter if we replicated that on the edge of the fan blade? And sure enough, so that's what owlet fans does. On a bigger scale, how many folks have ever seen a picture of a humpback whale, right? And you see those fins, and everyone knows those weird bumps on the edges of the fins, right? It's like, are those some kind of growth, or why does this critter have those bumps on the fins? And it turns out because they're really big wings, but they're not flying that fast through the water, and they do these incredible turns and pirouettes and stuff in the water. Those little bumps dramatically increase the efficiency of that wing at low speeds. And so that led to a company that called Whale Power that actually does wind turbines for low-speed wind areas that have those bumps on the blades that dramatically increase the efficiency of those wind turbines.
The aviation sector uses those technologies.
Yeah, and the aviation sector is using that on wing design now as well. So the next thing about moving fluids comes from a marine biologist who was looking at how fluids move in nature. And, when we try to pump fluids or move fluids around, we usually try to make it go in a straight line, thinking that's the most efficient. And what we discovered is nature doesn't tend to move fluids in straight lines. It tends to move them in curves. It tends to move them in a vortex. And he said, so what if I really study that and look at that? And so he started creating these impellers. So if you look at that impeller, it's called the lily, and it's also like the shape of a lily or the inside of a seashell, right? That shape. But what it also mimics is, think about when water's going down your drain and you see that little whirlpool at the end, right? That shape of air whirlpool in the end. If you turn that whirlpool into a solid piece of metal like that, and you take that and you put it in a great big water tank. Think of water storage tanks, municipal tanks, or process tanks that are the size of this room. It takes a lot of energy to keep those pumped and moving because you don't want them to get stagnant. You want to keep the water moving in there. So he created an impeller, a mixer, that is about this big, and it sits on a little tripod stand that puts it about that far off the floor of the tank. You turn it on, And in less than 30 seconds, all the volume of water in that tank starts moving in a toroidal fashion. Now, because it's also toroidal, it means that it minimizes friction, so when you turn the pump off, it will continue to do this for a very long period of time afterwards. So it means now that they're able to do mixers in large tanks, even with dense fluids that use 15% of the energy of the traditional way of doing it. Now, if you spin one of his sorts of turbines, and there are other shapes besides just this that do that at really high speeds, and so this is where the Navy's really interested. One of the biggest issues is we have submarines, and if you try to make the submarine go fast, the blades go faster, and the trailing edges of those blades cause the water to heat up so much that it turns to steam, and you get those bubbles, and you get cavitation sound, which is not a good thing, because all of a sudden now you can find your submarine, or people who don't want to find your submarine will find your submarine. Using propellers that use this technology, they can spin them up to 4,000 RPM with no cavitation. So that's a military application of this stuff. So now, and Bob's sitting in the room here, so I'm going to spill the beans on you, but it's already publicly known. One of the companies, Terrapin, my company, had the pleasure to work with during the 5-year period that we were doing a project with NYSERDA, the New York State Energy Research and Development Authority, of introducing biomimicry into companies in New York State. Humpback came to us, and the question was, so when you're making injection molding and you're making particularly what they do, which is precision parts, you want to make sure that you cool the part down evenly and effectively so that the structural integrity is really good and that you've got a good solid piece. And the way that you cool those pieces down after you inject the plastic in is you run coolant through the mold itself. And quite frankly, the way that's been done for a very long time is kind of guesswork. So if you could speed that up and cool it down evenly and faster, that would have a big energy benefit and a big economic benefit, because it means that you could produce more parts in a shorter period of time. And so the metric in injection molding is, what's the cycle time to make 100,000 parts? So the insight that the biologist who we brought in to work with Humpback had was pretty interesting. It's a new branch of physics called constructal theory, or constructal law. And it's about flow. And it comes from this insight that, have you ever noticed, if you look at the pattern of veins and capillaries in your hand, or in a maple leaf, or in a river delta, ever notice, or even an elephant's ear, right? It's kind of the same pattern, right? Ever notice that? That tells you what the most efficient flow pattern is for that three-dimensional space shape. And there's a whole set of mathematics now around that called Murray's Law that says, for this space shape, I can tell you the diameter and the length of the various components. So where does this play in injection molding? So rather than kind of guesswork or trying to match the shape of the component inside the mold, looking at how leaves have these sort of major veins and then these cross-connecting veins, so it's called a dicot pattern. So making a dicot pattern inside the mold and then running the coolant through there. And so the impact for Humpback was a 21.8% reduction in cooling energy cost. And going from about 30 days per 100,000 parts to 23 per 100,000 parts. So huge, huge boost. And so a local example of biomimicry in action.
And he didn't even mention that. It was not even mentioned in the nomination packet.
Yeah, it's funny. Suzanne showed me the material, and I'm like, they're doing a lot of other really cool stuff that Bob didn't talk about. So, Bob, thank you. So this gives you a sense of a sort of different by topic, different things that are going on, and then also sort of on the other edge are the industries. So if you go to the online version of this on our website, this is interactive, and you can choose, is it oil and gas, or is it optics and imaging that you're most interested in, and see which products in various stages of development are getting at that industry or going from the other side of sort of what's the function that's going on. And since we've done this, some of the products in here have moved further along in the stages. And there's some really cool stuff going on here in New York State. Another example we have in upstate New York is Yahoo has data centers up near Niagara. Cheap power, but it's actually fairly cool there. And so Yahoo is some of the most, well, they don't publicly acknowledge it, some of the most efficient data centers in the world, and they're mainly naturally cooled. And they wanted to take it even a step further, and so they had us dive in with them, and what we looked at was termite mounds. So how many folks know the story of termite mounds? Right? So
I just want to say all of the students from Harley raised their hand. Whoever their teacher is, well done.
So termite mounds are pretty amazing, right? They're if termites are the size of humans, scary thought, those termite mounds you see in the tropics would be more than a mile tall. And we think that termites are out there chewing up our house and chewing up plants and stuff, and that's what they're eating. No, they're just collecting material that they then feed to a mushroom farm that they maintain inside that big mound. And in the tropics, you get these wild temperature swings and really hot temperatures and changes in humidity, and those mushrooms are really picky. Those mushrooms will only survive in a very narrow bandwidth of temperature and humidity. And so that giant structure is actually a thermal and humidity regulation device. And so we see buildings like Eastgate in Zimbabwe, huge buildings that have been built using that system. And so we thought that's what will apply with Yahoo. Until we met some biologists here in New York State who'd really done a deep dive on termites and said, what we've been told about that story in biomimicry for last 50 years turns out not to be right. It's actually way more interesting than that. And we're like, okay. So there are some termite mounds that work as these giant thermal chimneys. There are others that are way more interesting. So if you take a termite mound and fill the mound with plaster and then wash away all the dirt that makes up the termite mound, and you have a plaster model of all the connections and all the chambers inside that, and you 3D scan it, and then you print it in miniature, it's indistinguishable from a human lung. Basically the same way that a lung works. And the lungs work in a really interesting fashion. We think about, we breathe in, so we take air in, and exchanges and it comes back out, right? But normally when we're breathing, we're actually only turning over the air in the top 10 to 15% of our lungs. Only when we're like flat out running and completely exhausted are we turning over a larger volume of that air. So, but how do we get oxygen in, right? That 10 to 15 isn't enough you'd think, to get all the oxygen in. So what's going on is there's a boundary layer in between those two air masses. And as the lungs move around and it sort of shifts around like this, the boundary layer does this, and you get little vortices occur along that boundary layer. There's the vortex again. And that causes gaseous exchange, and that's what exchanges the carbon dioxide and oxygen in the lungs. And that's what the termites are doing in these structures. There's a boundary layer in there. And as little puffs of air hit the outside of the termite mound, it causes these imbalances in pressure that create this rocking motion of the boundary layers. Now, you got to love the Germans. Of course, the Germans have a word for that, Pendeluft, which is literally air pendulum. So, I've been involved in a lot of really big buildings, and we do a lot of work in skyscrapers and super talls, and we do work in laboratory buildings and hospitals, and air changes per hour is something that you're always struggling with, and it takes a huge amount of energy to do that. These little critters with no outside energy are turning over that oxygen, turning over that all air volume in there basically about 7 times an hour, which is a flow rate that if I could occur in even laboratories or a lot of buildings, I'd be a hero, but it would usually take me way too much energy and mechanical systems to do it, and these little critters are doing it passively. So that's what we've got to be exploring with Yahoo about data centers here in New York.
Biomimicry, celebrating termites.
Biomimicry, celebrating termites, yeah. So are there questions about sort of product scale biomimicry?
Yes.
We've got mics too.
So we'll pause for a Q&A for a bit, and then we'll shift into biomimicry at the landscape scale. So you'll get another chance, and then we'll shift again into biophilia, and then you'll have multiple chances for questions. So if we don't get to you during this round, hold on to your question. We'll get it next time. And if you need a minute to come up with your questions, because you've got all these ideas, I'll kick us off. One of the perceptions that's out there often with advanced clean technologies and this beautiful eco-design is that it's only accessible to wealthy people, right? So that's one of the critiques we often face. So I wondered, Bill, if you would talk a bit about some of the work you've done with less privileged or maybe surprising communities.
So, biomimicry is a way of thinking. And so there's been a fair amount of work in recent years, not by us, but by others, of thinking about how do we solve some of the problems in refugee camps? Like, how do we clean the water? How do we clean wastewater? How do we do energy systems and all of that? And a lot of those have been biomimetic. Energy systems in nature tend to be dispersed and interconnected like an ecosystem. And so building a power system for a military base or a refugee camp done as a series of interacting cells or modules actually lowers the cost and gives you a lot more resilience. If one cell fails, you can pull power from the surrounding ones and have this sort of network of nodes to put the pieces together. And string it together really fast, because if you've ever worked in a displaced persons encampment, the rate at which the population of those can increase of people spilling in and needing to provide services is really pretty shocking. There was a question here.
Yeah. So I'm Tony Varacek from the Center for Imaging Science at RIT, and I have a couple of things that your discussion just inspired me to think about. So one is fish farming. I'm working with a student in Rwanda, and he wants to do an Internet of Things project that improves fish farming. So the fluid flow, the idea of the low energy fluid motion, sounds like an idea that I could give to him to help make that feasible in a low energy situation. So that's one. The other one is the students from Harley School had the mangrove inspired. And fantastic idea. And I see one of the issues would be how do you get it into the sediment? And then what you brought up with injection molding, thinking maybe this is a way you could start to injection mold these into a shoreline. It might take a little technology development, but...
There's been some interesting stuff on concrete forming using fabric, right? So you put fabric down in and then, inflate it and then put the concrete into that. That could be an interesting way to do it. On the fish farming, one of the biomimetic things that's been done, there's a guy at the Smithsonian who his specialty is Coralline Algae. He's the curator of algae, which only you'd have that title at the Smithsonian.
But you do get to walk past the dinosaur heads to get to his office.
And good friend. And he was spending so much time on the coral reefs in the Caribbean that the Smithsonian essentially said, Walter, we love you, but you're either here or you're there, and if you're there, you're not here anymore. And so Walter had to figure out how to bring a living coral reef into the Smithsonian. And this was in the 1970s, and no one had really ever done that before. And when they tried, it was all these complex chemicals, and it was never really stable. And so he figured out the paradox of a coral reef, which is, here's one of the biggest concentrations of life in a marine world, and it only works when the water is almost entirely gin clear and free of nutrients. So that's kind of like standing in the middle of the feedlot and not seeing any poo, right? How does it do that? And it turns out there are filaments of algae on the backside of the reef, what's called inaugural turf. That's what's cleaning the water. And so he started developing these matrix that you grow filaments of algae on, and off of that you clean the reef, and he's able to do living ecosystems from 30 gallons to 1 million gallons. So they're also starting to use that now for fish farming and an almost closed loop fish farming for tilapia and other stuff. And it means that you have, you harvest the algae and the fish eat the algae. And so really take a look at Walter Ade's work. Dynamic Aquaria is the book that they documented it all in.
I do have one question to add to, something you could explain a little bit more. Yesterday there was a seminar at RIT on critical design, and you have the term here, regenerative design.
Yeah.
So I'm just curious to explain
That's
a little bit more.
the next topic.
Okay. And I do feel that I should point out that this morning at the awards breakfast we were talking about the rate of extinction. What that means, with it being so rapid, is that we're losing the opportunities to learn from these species, in addition to just all the ethical, moral, and other reasons. Things like these algae filaments, as the coral reefs die because the CO2 absorption in the oceans is acidifying the oceans, the temperature is increasing. They're predicting that the coral reefs will be gone in my lifetime. So these are the things that we're losing if we don't hurry up and transform how we do what we do.
Yeah, and an unfortunate recent example was there were some frogs in Australia that the frog would carry around the eggs inside its mouth and its stomach until the eggs matured and then released them. So, how does it do that? Because you think of stomach and all the acids and stuff in your digestion system. How did it correct the system to protect those eggs? That frog's now extinct, so we'll never know. So, for me, there's a pretty brutal example of from biomimicry of we need to keep these things around so they can teach us what we need to know.
I just want to say we have a bunch of questions, and we're running out of time for this section. So can we just take a few, like maybe a couple, real quick, and keep them as quick as you can?
Mike can wait till later. Mike can wait till later.
Okay.
Okay.
Because it's broader.
Anyone else have quick questions related to the biomimicry and products? All right, we'll move to the next, and then we'll get to all these bigger questions that folks have. All
right, so this is 111 8th, the building we discussed earlier. And using the basis for this work was from the Wildlife Conservation Society, the Bronx Zoo folks. They did the project called Manhattan, which remaps Manhattan back to its ecosystems at the point of European contact. The techniques and the computer software that they have developed for this, they are now gearing up to share with other cities so that other cities can do this investigation. And with this, for us, what's great, because our office is in Lower Manhattan, we have a number of projects there, to understand sort of context for the project, we can type in an address and see what the ecosystem on that site would have been, and then go from there. A slightly more simplified and streamlined version of this is the work that's being done with Interface, which is a carpet and modular flooring manufacturer that had committed back in the 1990s that by 2020 they'd be a zero emissions company, zero carbon, zero water, zero waste, and that was their mission zero by 2020. We're a year and a half away from that, and they are almost entirely there. They've reduced their carbon footprint, even though the company's grown by more than half. 85% of their energy is renewable, zero waste, and in fact, they now are even got a project going with the Zoological Society of London where they're taking old fishing nets, subsistence fishing nets, the ghost nets, and working with the indigenous villages, buying the nets from them, and then having them reprocessed back into fiber for making carpet with a company called Aquafil out of Italy. So one of their projects is called Factories of Forest, and it comes from the insight of their owner asking a question to some biologist saying, could my factory ever perform as well as what the forester used to do? And so how do you figure that out? And so with B3.8 and their team of biologists, looking at the local ecosystem, saying, okay, these are services the local ecosystem provided. They fall into 5 broad categories. And from that, we can develop a set of numeric indicators. And so these are numbers that are indicative of what that ecosystem is doing, and then they get translated into the equivalent for the built environment, and then become like the work with Google. Okay, so how do we address that within the fabric of our buildings, and how do we get at that? And so it looks at not just the operational energy, but even the energy that goes into making the carbon that goes into making the materials themselves. And Interface is the first company to commit to what's called take back or drawdown, saying getting to carbon zero is not enough. We're going to go the next step, and we're actually going to see how we run the company, and every product that we make captures and uses carbon and locks it up permanently. So we start reducing the amount of, CO2 itself is not the problem. CO2 is really important. We're made of carbon, right? There's carbon everywhere. The problem is we just got a little too much of it in the wrong place in the atmosphere. And so let's put it let's put it back in products, let's put it back in the ground, let's put it back in other places, and use it for life. And so that's sort of the approach they're doing. So when you have these sorts of metrics, there's a lot of conversation about, in the design world, about regenerative design and restoring ecosystem services and all of that. But it's also, most all that conversation is about process. And what we realized was, great, process, but I want to know if I'm actually getting to where I want to be. And so if I have a building that matches the carbon balance of that local ecosystem, matches the water coefficients of that local ecosystem, starts re-increasing biodiversity on that site, starts looking at the nutrient cycling that site would have done. If I can mimic that with my building, then I'm probably doing a pretty good job of regenerating those ecosystem services. And so it's a way of giving metrics to regenerative design.
This is interesting. I have memories of studying this company in grad school 2 decades ago, and they were blowing our minds then because their main product was made of all these toxic dyes and petroleum products. And part of the reason they were trying to rethink their business was because the scraps from their product, from their carpets, was actually considered toxic waste and it was really expensive to deal with as toxic waste. And you're thinking, well, but wait, like you're putting the main product in your home and your kids are crawling around on it. So they redesigned the whole product to use natural materials, natural dyes, and then they started composting the scraps. So it's not, again, like we're not just tinkering around the edges, we're rethinking completely how we make things and do things. And I love that now, 20 years on, they're into this whole new realm. And I think that's one of the cool things about the companies and the efforts that we highlighted this morning is that you could see Bob was was working on wind and some things that were proven 15 years ago, and now he's pushing the envelope on some newer technologies in biomimicry, and I think that's fantastic. And maybe one of the things that we could think about as a community after this is some type of sustainable business roundtable. Once every quarter or something, we get business leaders that are trying to solve these problems together in the region to share information and ideas or something like that.
Yeah, and Rochester has a unique pool of scientists. You've got a science culture here that most cities would kill for. It's still here. And so engaging that community in these sorts of conversations, I think, would be really fantastic. When we were doing some of the early biomimicry work, we found some of the resources, particularly when we were doing work around biomimetic optics and optical sciences and light transmission and things like that. The knowledge base is here. It's in this city. Just got to shake it loose and get it moving. So questions on factories of forest or ecosystem biomimicry?
All right.
Mike's got one.
Still apply.
It's going to be really good.
So Mike Bowler, I'm a marine ecologist by training, right? Didn't do that great of stuff that you talked about, but I'm thinking about how scientists, we specialize and we get trained and we get so focused, and then you get out in the real world once you've gotten your graduate degrees. So we don't necessarily aren't going to make the connections that you're making, right? And the people, your company and you are making. How can scientists maybe contribute better? Like, what should I be telling my students about how they can think about these things in the future? Where can they make those connections to maybe contribute to these kinds of biomimicry type questions?
So that's it's one of the things that wildlife biologist Janine Benyus with the biomimicry folks have been trying to say with more and more biologists is saying, hey, let's not just study what the critter is in the ecosystem it lives in, but also how does it solve various problems. So actually asking questions about functional biology. And you'll find that surprisingly, those are questions that don't get answered that often. But we got 3.8 billion years worth of experimenting that's gone on here on the planet. Now, 99% of those species got recalled, recalled by the maker, but there's a lot to be learned from that. And so it's asking the questions and framing the questions of, how is that elephant keeping from overheating, right? How, questions like that, functional biology questions, which a lot of times in schools, those are not questions that get posed.
I would also add that, I understand the way that our educational systems are set up, to some degree require a bit of siloing. But to the extent that you can encourage students to maintain their intellectual curiosity broadly, because so many of the solutions to our problem come from a completely different field, that's a big part of what I love about your design community is people are curious about everything. And inevitably, you solve your problem from something unrelated. So.
And sometimes it's just learning how to ask the question. Ask the question, ask the question, ask the question. And reframe the question and ask it in different ways. The stuff pops up. And some of it's just weird observation. We know a materials scientist who was trying to do stuff around adhesives, and one day a hummingbird, he was in Texas, and flew into his window and fell, and he picks up this hummingbird before he releases, and he's going, okay, so you guys make these nests, they're really strong, and they're made out of just fibers and stuff, out of spider silk and these other lightweight materials, and they're incredibly strong nests, and how they bind them together. And he says, well, let's spit. And so before he releases the hummingbird, he takes a swab and gets a little saliva from the hummingbird, and then cultures it and discover the hummingbirds are able to, through a chemical reaction with their saliva, produce pure strands of binding cellulose. Right, so he then starts growing this stuff and making these new fibers and all that, from just sort of asking that sort of bizarre question of, how do you make your nest stick together?
Bill, my name is John Schwartz. First, I'd like to thank you for stimulating my thought process on different ideas. One of the things that I see that you have right up there is the use of carbon and how it relates to us and where we're going forward with our carbon footprint. And I was wondering, in your expertise, in your experience, where does like biochar come into play with being able to utilize that for helping in those situations?
So we're really interested in biochar, and in fact, it took us a long time to find a big enough producer. So we do a lot of work with Interface, that carpet company, and they want to, in every carpet tile they make, not just be carbon neutral, but actually could the carpet tile itself permanently sequester carbon in it. So that actually each carpet tile you make has a negative carbon number on it. And so we're looking at two techniques with them. One is there's a fair amount of carbon that goes into the backing. And so we finally found a source of biochar near their factories in Georgia that may be a big enough supply to supply that biochar. The other is a different technique. The other material that gives carpet tiles their heft is there's limestone in the plastic in the carpet tile, and limestone is basically old coral and old seashells that's fossilized and then becomes stone. And what is that? It's calcium carbonate. So how do those critters make it? Well, they biomineralize it out of the seawater. And so there's a company now called Blue Planet that finally has got a installation going under construction in California that'll take 50% of the carbon dioxide coming out of a power plant and through an aqueous water-based process, biomineralize that into little chunks of limestone. And so we're looking at, between the biochar and the limestone, we might be able to sequester as much as half a kilogram of CO2 per carpet tile. So every carpet tile you put down. And once it's in that carpet tile, they infinitely recycle their carpet tiles, and even if it goes into a dump, hopefully not,
It's still sequestered.
it's never going back into the atmosphere. It's always there. It's always locked up. So imagine that every time you make your product, you're actually lowering CO2. So yeah, biochar is a cool thing, and it also, particularly if you look at the indigenous use of biochar in the Amazon, there are huge chunks of the Amazon that were essentially farmed by the indigenous people, and huge agroforestry, and the way they made that, lateritic soil that when it gets exposed, not turn into concrete and stay productive, was they added biochar and small bits of ceramic into it. And so that's called the black earth, the loma prieta, and that stuff is over huge regions of the Amazon.
And just if you're not familiar with biochar, it's basically a fancy word for charcoal used in. It's basically, we're talking about black char. And it turns out it's an amazing soil amendment. We've done a little experimenting at our farm on Keuka Lake with biochar. Unfortunately, we don't have good systems in place right now in this country to compensate farmers for investing in things like putting char into their soil and doing these kinds of things. And we don't have a lot of good field data because soils are so diverse. And the char is so different depending on what you make it out of and how you make it and then how you treat it and what kind of soil you put it into. So there's a lot of work that we need to do around how to use it so we can get it used much more quickly.
So getting carbon back in the soils is really important. We've lost so much carbon out of the soils, and it helps, and it hurts soil productivity. But also there's some other amazing stuff happens. So the zoo is part of this effort to take vacant lots around the city of Rochester and basically turn them back into native prairie as a park form, which is awesome because it's way less maintenance than mowing it all the time. And B, the tall grass prairie that was in this region and through the Midwest has incredibly deep roots. These roots go down 25, 30 plus feet. And so there's sort of like carbon icebergs where you've got less than 10% of the plant mass is actually above the soil and 90% of it's under the soil. So when that plant dies, the vast majority of that carbon is permanently locked up in that soil. But also having that amazing root mass means if you've ever been in an intact example of the regional tall grass prairie in the middle of a thunderstorm, and you normally would have puddles and water running off everywhere, you're standing in the middle of that prairie, and it feels like every single drop of that water is getting sucked into that soil. And so it's also an amazing way to deal with stormwater issues as well. So, join the zoo in that conversation, the work that the zoo is doing around that. And I think some of that is also going to be applied on the river restoration project here.
Carbon icebergs. That should be the name of our band. Do we have more questions before we move to the next segment? One more up here.
First of all, thanks for sharing such a diversified application of natural inspiration, right? Thank you for that. My question is, when you're talking about biomimicry, what is more prevalent as a practice? Is it identifying an inspiration from nature and then trying to find an application for that? Or first defining a problem and then going to the nature and finding a right solution for that?
A lot of folks start with the first process of, ooh, nature does this, and can we replicate it? But the more successful ones tend to be, there are a few examples like Velcro, which is that first case. But more and more what we're seeing are companies asking, okay, conventional engineering, conventional design didn't solve this. So the process with biomimicry is to then frame that question and say, okay, how is nature dealing with this? And find, so the Biomimicry Guild and the Biomimicry Network have a website called Ask Nature, where you can go in and ask functional questions, and you get this catalog up of this critter did it this way, and that critter did it this way, and hopefully find some ideas through that process. There are also, the San Diego Zoo is experimenting with and trying to do stuff with that with some biologists on the West Coast as well. And I know there are other zoos that are in this conversation of bringing biologists in and having those conversations at the zoo and looking at the critters that are at the zoo at various zoos and saying, okay, how are they solving different life tasks?
Yeah, the example that comes to mind for me is folks were trying to figure out how to stick things together underwater, building structures along the coasts and saltwater where there's wave action. And they looked at mollusks and how they adhere to rocks and pilings and things, and recreated that substance.
All right, so why don't we move to biophilia? So I talked about this study, and Roger did something after this, which was, and this was with Chalmers University in Sweden, team. They were looking at cardiac patients. And they said, okay, we've seen evidence that seeing a view of nature reduces stress, improves healing rates. But if you're thinking about going into cardiac surgery or just after cardiac surgery, you're in a sterile environment. So there's frequently there aren't windows, and there's no way you can have plants and animals in that space. So they said, let's do an experiment where they had a sheet of paper about this big, and it was either a blank white sheet of paper or a picture of nature. And they showed it to people either before or after the surgery, and they found a dramatic drop in heart rate and blood pressure and an increase in healing time of the people who saw the picture of nature before or after surgery. And it wasn't staring at it for a long period of time, but just briefly seeing it. Now, to make sure it wasn't just any picture, they replicated the experiment again, where they did blank sheet of paper, scene of nature, or a piece of highly abstract, spiky art.
That's enough to get my blood pressure up. I don't know.
They actually didn't finish the experiment. They found that the abstract piece of art caused people's heart rate and blood pressure to spike up, and they felt it was unethical to do that to cardiac patients. So they terminated that experiment. So that does answer the question of, so we know that just seeing a picture of nature is beneficial, right? And so Peter Kahn and his team at the University of Washington said, is that enough? And so they did this really interesting experiment where they gave people a stress task, and then in recovery they had one of three conditions: staring at a wall of gray curtains, looking out window to this fountain and flowers and trees on the University of Washington campus, or what you're seeing here, which is a flat screen, high definition television of the same dimensions and aspect ratio as the window, and broadcast live on the television was the view out the window. So how helpful do you think the curtains were? Yeah, not so much. The psychological response to the flat screen television and the real view was pretty much the same. Both were beneficial. Seeing the flat screen image on the flat screen television lowered blood pressure and heart rate, but not as much as seeing the real view. And so we asked Peter why, and Peter had the answer we didn't want to hear, which was, we don't know. Fortunately, we get to work with lots of other scientists, and so we asked some of the neuroscientists we work with and some of the optical scientists. And the optical scientist was actually the one who said, well, this is a really easy question. We're like, okay, tell us why. We have binoculars, and we have two eyes, each forming a cone of vision that overlaps and creates the condition called parallax. And so that's how we see things in 3 dimensions. And all I have to do is move my head just a little bit, and what I see 3-dimensionally changes in the real space and a real view. But it doesn't matter how great that screen is, no matter where I am in the room, it's still the same image. And the brain processes those two things differently. So one's beneficial, the real is better. In Japan and Korea, there's a whole bunch of work. They don't call it biophilia there, it's called forest bathing. So Shinrin Yoku. And they decided to take it a step further and not just look at blood pressure and heart rate and psychological response, but they said, what's going on with the stress hormones in your body? And so one of the actually surprisingly easy ways to test that is take a spit sample. Because in your saliva is cortisol, and cortisol is a really good indicator of the stress level in your body. And so they had these experiments where you had a stressor, and then you either walked in the forest or walked on an urban street or sat in the forest.
Or the zoo.
Or the zoo, or sat in this unfortunate individual sitting in a busy urban corner. And
Conference room.
windowless conference room. So no surprise, cortisol level was lower after that experience. The big surprise was that multiple hours after that experience, the cortisol level of the forest experience was still lower. And in fact, if you go on vacation, remember we talked about beach, mountains, park? If you go on vacation there, when you come back, your cortisol level can actually stay down for as long as 2 weeks after that exposure. So being out in nature really, really can make a difference. And so there's even work going on, particularly in Korea, looking at how that exposure to nature changes the performance of the immune system as well. This was the cognitive development study I mentioned earlier. We are about a month and a half now into an experiment in an inner city school in Baltimore. This is a STEM academy in West Baltimore. It's an unfortunate neighborhood. The children are, some of the kids are afraid to go outside because there have been attempted abductions on the school campus. They found dead bodies on the school campus. It is a tough neighborhood. But these kids are motivated, and it's an amazing school with a nature theme to the STEM work that they're doing. This is a 7th grade math classroom. And this is what the classroom looked like. And this is a rendering of what was done with that classroom this summer. Now, 2 math classrooms, 7th grade math classrooms, on the same side of the building, on the same floor, got new paint, new carpet, new ceiling, new blinds. This one got it with all stuff that has biophilic components. So fractal pattern of nature on the wallpaper, carpet that mimics stone and moss, a waveform for the acoustic ceiling, and the window shades actually have tree branch patterns in them. And so Morgan State University and the neuroscientists out of the Salk Institute are monitoring these children in the 2 classrooms for this school year to see differences in outcome between the kids in this classroom and the other classroom, and children in the prior years in those same classrooms, and because the teachers who've been in these classrooms for several years, what the outcomes for the teachers are in these 2 different classrooms. And so by next summer we should have, hopefully we'll have results and we'll understand. The hope is that, obviously we'll see better performance better outcomes for the children and for the teachers, and then use this as a basis for redoing all the classrooms in that school.
Is this the kind of thing where you could get, I'm thinking about like working in schools with limited resources, is this the kind of thing where you could have artists paint, just branches and trees on the walls, and it doesn't have to be expensive.
Right. Yeah.
Cool project.
The other thing that kids and volunteers worked with a professional landscape company and planted some gardens inside the fenced area of the surrounding the on this side to make it a better environment and a safe space for the kids to be out and to do some agriculture and horticulture lessons. So one of the ways that nature changes the brain function is, when you're out looking at the animals at the zoo, or you're out walking through Seneca Park, or you're out along the lake and all that, your brain's actually functioning in a different way. You're operating in what's a state that's called soft fascination. And
album name.
And it's a theory that's been around for a very long time that, when you're in nature, the brain quiets down, but you're more focused. And it's been in the last 10 years that neuroscientists have finally caught up with that and actually discovered that, sure enough, that's what's going on, is that the prefrontal cortex activity quiets down when you're experiencing nature, and other parts of the brain are operating in a way that you're expending a lot less energy. And so when you come back and you need to focus again, you have much better cognitive capacity. And so that's called attention restoration theory. Now, the question has been, how long do I have to see nature to have this happen? Is it 5 minutes? Is it 15 minutes? Is it half a day? Is it an entire day? How long does it take for this to kick in? And so this was a particularly tasty experiments some friends of ours at the University of Melbourne in Australia did. They gave people a stressor. They put them in an fMRI machine to watch changes in blood flow and operation in the brain. And the question was how long, or would they see a differential in brain pattern? And so they were looking at, they gave them a stressor, and the recovery was either seeing this asphalt roof or that same drawing with it rendered as flowers. Like the gray curtains, the asphalt was not particularly helpful, but within 40 seconds of seeing the flowers, the brain shifted processing mode, the prefrontal cortex quieted down, and they came back and did the recovery task with much better cognitive performance after seeing the flowers for 40 seconds. So that tells you how fast this connection to nature can shift what's going on in your body. It's pretty dramatic. This is a direct experiment in that connection to nature. This is a call center for a utility company, municipal utility, SMUD, in Sacramento. It's up on the second floor of a LEED Gold building. It has great daylight, good indoor air quality, good thermal performance. It's a raised floor with displacement ventilation, so that small round vent by every workstation, everyone gets to adjust their own airflow and temperature. A really good green building. And all of the workstations were perpendicular to these windows on the second floor, the view out to the surrounding field and the trees there. But because they were perpendicular to the window and you're staring at your computer screen while you're answering calls from pissed off people because your power's been cut off or the bill's wrong or something like that, right? You're actually not seeing what's going on outside. Now, another thing's happening too as well, a physical thing with your eyes, and that is the eye works in 4 different focal lengths. The first is near, and near is less than a meter away. And that means that the lens is rounded, and the way the lens in the eye rounds is all the muscles in the eye contract. Now, think about that. How long can you clench your fist, clench a muscle before you start getting tired and fatigued? And imagine if you're staring at a computer screen all the time and all the muscles in the eye are trying to do this, right? Surprise, you get a headache, you get tired, you get fatigued. So then, next visual length is 1 meter to 7 meters, so to about 21 feet. And then you have another visual focus length, which is up to 100 feet. And then beyond that is the infinite visual focus. So anything more than 33 meters or 100 feet away is the infinite visual focus. And the way the lens works to do that is the lens completely flattens by all the muscles in the eye relaxing. So if I can get you to look up and look away at nature every 20 minutes or so, I can get you to relax the lens and really get rid of a lot of fatigue and headaches and stress. And if I can get you to look at nature for 40 seconds, I get potentially attention restoration theory, ATR. So what they did here was really simple. It cost them about $1,000 per workstation because it was all set up in a running office. They moved the desk 11 degrees off a perpendicular. That's it. 11 degrees off perpendicular. But the effect that it had was really enormous because now movement outside the window is now in your peripheral vision. And the way the eye and the brain works and processing in the brain is that this in front of us gets processed much slower than that right here. And as one of our friends who's done a lot of zoo work and evolutionary psychologist says, which tiger eats you? The one you see sitting right there or the one jumping out of the grass over here? So it would make sense that motion here gets our attention much, much faster.
That's why we all go, squirrel. Squirrel. That's it. Go. It's not me. It's my evolution.
And so by doing that, they increased call handling capacity by 7%. And that was a return of almost $2,999 per workstation. And so here's a direct financial return on Biophilia. Here's that chart again. We're also, there's a little bit of evidence around some stuff around creativity as well that we didn't put in the chart because the science is still a little messy, but there are some of the patterns that help with creativity as well. And so what we're seeing with designers now and some of our clients, and particularly with Google's version of these metrics, is the way the Google design teams uses literally as you write a narrative and say, who are the users going to be in this space and what are the outcomes I need to support, and then it helps me choose, because let's face it, even I can't remember all 14 patterns most of the time, and so we do these cards, and that helps us remember and then filter which one. Now, there are 14 in this. We're actually working on a new one that we hope to include in a book we're working on. And it's a really fun pattern. And just in the recent last 2 or 3 years, the science has gotten better on it. Awe. 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 How many of you have ever been to the Grand Canyon? What's the facial expression you see on people when they first experience the Grand Canyon? Right? Go to Kamakura and see the great Buddha, or go into the great cathedral at Amiens, and you walk into that amazing nave and you go, right? It's a really amazingly distinct brain response and physiological response. And a friend of ours, a neuroscientist at NYU at Vessels, said, it's fun to watch this one in the brain. He said, it's an overload of the brain, actually. You get all these different inputs, and different parts of the brain light up, and it all rushes forward to the prefrontal cortex, and the whole thing just lights up all at once, boom, like an overload. And the physiological response is your body stops, your jaw drops, your eyes go wide, and your heart rate changes, all sorts of stuff in the physiology change. And you go, awe. Now, awe elicits a psychological response of, there's something in the world a lot bigger than me, right? First time you experience an elephant up close or a whale, you're going to get that as well, right? And there's some interesting things that people are more charitable, right? So there have been some experiments with awe where they gave people a donation basket, and after an awe experience, they gave more money. Right? Something bigger than me. And so that's one of the next patterns we're working on is awe. I'm going to give you a couple examples before we end here on this section. One is probably the most improbable space you could ever think of trying to do biophilia in is an industrial bakery. So how many folks know Cliff Bar? Yeah, okay, so this is their first bakery built from scratch. Here's a company who's devoted to making tasty performance bars for people doing outside sports, being outside. An industrial bakery is a 1/4 mile long, sterile space. No artwork, because it might collect dust and microbials. No natural materials, obviously no plants, animals, or water. It took 9 months to be able to get permission to put windows into the space, which was great for the folks in the daytime shift, but not so helpful for the folks in the swing shift or at night. And so what do you do in a place like this? Well, normally, our rule is, if you're going to do biophilic design, you don't try to do all 14 patterns. You do 1 or 2, and you do them really well. We broke the rules here. So the front part of this building, where the offices are and the break areas are and the training rooms and the meeting rooms and these other spaces where people come when they come on break out of the sterile area, is, you know, the complete zoo, complete menagerie of biophilic design. You name the technique, it's in there. It's, you know, biophilia overload for while people are on their 15 or half an hour break. So kind of give people a recharge experience in that. The other fun thing that's being experimented within the bakery is you have these 30-foot high white metal walls. And Cliff Bar has this great social media feed. Every day, people are sending them pictures of, hi, I'm on my kayak in the San Juans. Hi, I'm hiking on the shores of Lake Erie. Hi, I'm in the forest. Hi, I'm in the vineyard.
And all I have is this damn Cliff Bar.
With my Cliff Bar and getting my picture taken, right? They get this incredible social media feed of people in nature eating a Cliff Bar. So a 30-foot high metal wall is a pretty damn good projection screen. And so each day there's going to be a different picture of someone out in nature with a Cliff Bar. And so is it as good as real nature? No, but we know that seeing that image will lower people's blood pressure and heart rate and help with their stress in the space. And originally it was going to be one. Now they're talking about doing 4 different locations in the bakery. I haven't seen where the 4 locations are yet. But and they've got an existing bakery in Indianapolis that they're going to that we're going to modify, that they bought from another company. The other question we've asked, we do a lot of observational studies and we're doing a lot of post-occupancy. And so we were supported to do a study because we do a lot of work with hotels, both on brand standards and green building stuff and supply chain. We wanted to look at, did biophilia change the guest experience and the economics of hotels? And so one of the things we looked at was we categorized different patterns occurring in different spaces in hotels, and then we did an observational study of one kind of space, hotel lobbies. Now, if you look at hotel lobbies in grand old hotels, they were kind of the living rooms of their communities. But in recent decades, hotel lobbies have become pretty disgusting spaces, man. You just go in and check out, and you just move through, and they were transactional spaces, but you didn't necessarily, they weren't designed to hang out in them. And hotel companies are now kind of asking, was that a mistake? Did we blow it? And so we did an observational study of 6 hotels in Midtown Manhattan, 3 with biophilic design and 3 that were just conventional. And what we found was in those hotel lobbies with biophilic design elements, a 36% increase in the number of active or passive users in that hotel lobby. So that's people hanging out just by themselves or meeting with friends, and more importantly for the hotel, maybe buying a coffee, maybe having a drink, maybe getting a little food. And hotels are all about what's called TRevPAR, which is the total revenue per room. And if you can increase that without having to sell another guest room, you know, by selling food and beverage and all of that, that's a home run. And in fact, what we discovered in one of the hotels we did observation on was 54% of the people in that space were active or passive users, and a lot of them weren't even hotel guests. There were people coming from the surrounding neighborhood because it was just such a great space to be in. And so this hotel was making all sorts of money off their little bar and cafe in the lobby by people just coming out to want to hang out in this space. So biophilic design can change the economic performance and the way people use and perceive space. And then we're fundraising to do this experiment now. Going beyond just observing how people are using the space, we actually want to see what's going on in their brains. And so with the Cloud Lab at Columbia University, we're hoping to do an experiment in what's called neural cartography. That's where you wire folks up and you watch the changes in brainwave patterns in their brain. And as that happens, and they move through a space, the map underneath them, the pixels on the map change colors. So the color of the pixel tells you what brain state people are in. And so you take a whole bunch of people through this experience in different weather conditions, different times of day, different demographics of people. And then you start layering their maps on top of each other. And where you see consistent color patterns emerging, that tells you that it's not the demographic or the weather condition or other things going on. It's likely the design of the space that's inducing that brain pattern.
Yeah, that's cool. That's great.
So that's geeking out a bit on biophilic design.
That's awesome. So we have about 10 minutes for last burning questions. We've got one back here.
Yeah, hi. I'm just curious, and this might be slightly off topic, but in your research around the impact of environment on, brain studies and focus and all of that, how does meditation compare to looking at an environment that is beautifully decorated with gardens and sunlight and all of that?
Can you tell us who you are?
Oh, I'm Anna. I work with Humpback Plastics.
So meditative state is the high theta state within the brain, and we see in an intense nature experience that you can get that state as well. It's sort of self-inducing, a bit of what you get with the attention restoration effect in the brain. Now, the caveat I have to have on this, particularly because we are doing more and more stuff with neuroscientists, is what we're learning from the neuroscience is it can tell us what, it doesn't tell us why. And so we have to sort of guess about what the response is on the why. But you'll notice in really good meditation spaces, there's usually a fair amount of natural materials and calming stuff in experience with nature to help induce that state.
Hi, Bill. Hi, can you hear me?
Yeah.
Kate McCardle with New York State Pollution Prevention Institute. First of all, thank you so much. I think everyone in this room is really inspired by the work that you're doing, and clearly there's researchers and academics and businesses here that are going to take this and incorporate that into the work that they're doing every day. And so many of us in this room are doing and trying to do this kind of work daily. Of course, with that comes challenges, and often the folks that are on the front lines and doing this feel like there's laggards everywhere. And even hearing Suzanne talk about bringing groups together, there's been many efforts to do that kind of work. And the group of us that work in these fields think, well, maybe Rochester isn't ready yet. Maybe now is the time. Through your experience, whether it be with Terrapin or in the other work that you've done, could you talk a little bit maybe about challenges within policy or specifically with funding? Because a lot of times when companies have these ideas to make change, they come to these challenges, and maybe a little bit to inspire folks that may have challenges to kind of move forward. That's my first question. Right. And while you think about that, and then the kind of second piece of that is Rochester has this history of incredible businesses with great innovative thinkers, as you said, but also have a history of sometimes not seeing things right in front of them. So any advice for that, for the community as well? And one piece, I've already got my action item. Clearly, we need decision makers and policy folks just to step outside for 5 minutes. So if we can remind them after these big meetings that we have as collaborations and we're getting together, for all of us in the room, let's just walk outside for a little bit. So there you go. Sorry for the long question.
Get them to the zoo.
There you go.
Get them to see the critters at the zoo. So in New York State, on the biomimicry side and some of the innovation stuff, if I can make any tie with energy, there are ways of accessing funds through NYSERDA. So in the biomimicry experiment we did, supported by that, the stages were, if there looked like there was a viable solution, then we lined them up for other programs within NYSERDA that brought proof of concept funding into it. And so between the 15 companies that we worked with, between private money and the state money, we raised $5 million in proof of concept funding for those companies. So there is money in the state for helping support that kind of innovation. The other is just this whole, for us, the biggest surprise in biomimicry for us was sort of just like we thought the biomimetic solution for the data centers was the stack effect termite mounds, and just learning from biologists that, well, that's interesting, but that's not what they're actually doing. So one is learning from the really learning from biologists, and two is also kind of learning how to frame the question to biologists. It's not like, fix this. It's like, okay, so what's the fundamental thing that's happening in this process? And then framing the question and saying, is this a heating thing? Is this a cooling thing? How is nature framing the question so it can be asked back to the biologists in a functional way?
Okay, we have about 5 minutes, so we could squeeze in a couple quick questions. You want to do both of them?
There's one here.
One
yeah.
here.
My name is Ram Shrivastava from Larson Engineers. Three things. We deal with water, wastewater kind of issues.
Yeah.
So you read about mushrooms being talked about as that will save the world, the mycoremediation for soils. So you look at the certain types of mosses that disinfect. So rather than adding chlorine and then trying to take it out because you got to meet DEC requirements, why don't we just use those kinds of species to kill the organism? So using nature, using these forms of nature, and you mentioned mushroom before, and the other thing I'm looking at is the fungus. So we are having waste management processes where you can use certain processes. So how can we use those things and replace the man-made decisions or designs with the nature-based designs?
Well, fortunately, in New York State, there are, it's one of the first places in the country where we have licensed and operating biological wastewater treatment systems. A famous type is called an eco-machine or a living machine. And there are some at some of the state rest areas, and there are some that the state itself built. And there's one at a big conference center in Rhinebeck, and there are a number of those around the state. So the heavy lift on getting biological wastewater treatment systems approved by the state DEP has already, most of that effort's already been done. In some other states where no one has done them, it's a bigger lift. So we're fortunate here in New York State that we've got other folks who've done the heavy lifting for us. And so, those are biological wastewater treatment systems that are literally asking, how does nature clean water? And it's usually doing engineered ecosystems, either algae-based or marsh plant-based, where you use the root matrix and the bacterial films on the roots to do the cleaning. And on some of those, it's really astonishing. The water quality that comes out of them is essentially drinking quality by the time you get done through those systems. And then the microbial stuff, particularly the mycelia mats, has really been interesting. And the military in particular has been funding a bunch of work on that, on breaking down. Turns out they're pretty good at breaking down biological weapons, and they're pretty good at sequestering or capturing really toxic heavy metals as well, and then locking them up. So there's some interesting work going on, largely supported by the military on that stuff.
Hi, Thomas Neumeier from the Harley School. Thinking about that question, my heart pounding, thinking I need to go outside. You had alluded earlier talking about visionary, sort of the optics of looking at different forms of nature and this might kind of answer the question, but have you looked at using virtual reality and kind of that form of looking at nature to possibly, for people who may not have access to nature, looking at that to reduce stress in ways?
So I didn't put it in the deck because we just made the slide less than 2 weeks ago. A team of friends of ours at Harvard did this really interesting study that just got published a few months ago, unfortunately in a journal that has a paywall around it, and so we're now sort of clandestinely with them spreading the paper around. But they looked at giving people a 5-minute exposure, either sitting in a windowless classroom or sitting in a lounge outside the classroom with a view out to the Charles River and some plants around them and a metal perforated screen with biomorphic patterns on it. And they were asking blood pressure, heart rate variability, hormone stress level, and various measures of cognitive performance. And they, so it was a multi-step experience, and the exposures in those two spaces were only 5 minutes in each, in the exposures. And what they found was a significant difference, heart rate variability, heart rate, blood pressure, and a 14% increase in memory task cognitive performance with the biophilic space over the real space, over the windowless classroom. They replicated the experiment where they had people sitting in the windowless classroom and with VR goggles in and being in a VR version of that exact same classroom, seated in the same place. And they replicated it in the lounge area with the view outside, seated in the exact same seat, but seeing it in VR. And what they found was the results in the VR were almost indistinguishable from the real. Now, that was a result that kind of we didn't want to hear, and the Harvard folks didn't want to hear either, right? I want people to experience real nature. But the caveat on that was the only variable was the visual input, right? So they were getting the same temperature, the same smells, the same acoustic experience, the same haptic touch experience in both of those settings. VR will only give you the visual, right? It doesn't replicate all those other things. So I think if they replicated that experiment where you actually were outside and then you were in a VR or cave mat, I think you would see a differential in that, because we get so hung up in the visual that we forget that we've got lots of other senses. You say we have 5 senses, actually we've got about 16 that have been cataloged now. And VR only replicates the visual. Now that dominates a lot of our sensory processing. And in some places, I think VR may be beneficial. But whenever possible, I want folks to get real, real tactile, smell it, get it, because when you're smelling things, you're touching things and all of it, it's not just you're sensing it, it's actually those chemical compounds are coming into the body and interacting with the body and all that. VR will never do that.
Well, I have to say, after the IPCC report that just came out recently, I needed this. This is, I think, really lifts my spirits and makes me a lot more hopeful. I don't know, Bill, did you want to say any last words before you close it up, Pamela?
Thank you. Thank you for coming, and thank you for your time.
Thank you all for coming and experiencing this and sharing this with us. Bill, thank you for your genius. I think there's not a question that you're incapable of answering around this topic, that your breadth of knowledge and experience is amazing. Thank you for bringing it here and sharing it with us.
So much we don't know.
Suzanne, thank you for the genius
so much we don't
thinking
know.
to bring him here to share and for all the work that you do. And I would be remiss if I didn't thank CPL for being our presenting sponsor and really making Bill's presence here today possible. So thank you to all of our friends at CPL who have made a big difference in making naturalistic habitats at the zoo so people can have their ah moments. What's one thing that we've really noticed with the new expansion is that people come in and their jaws do drop. They have that awe experience in nature. So thanks for plugging zoo visits so well. By the way, they're awesome without towing little children with you because you get to have your own experience in nature. So hope we see you out there, and thank you again for sharing this with us.